welcome to today's webinar, Understanding the New ANSI NEMA IM 60000 Standard. My name is Mike Moran. I'm the Vice President of Business Development and Engineering at the Gun Company, and I will be your host for today's session. First, I'd like to thank everyone for taking time out of your busy schedule to attend today's webinar. Before we begin, I want us to cover some basic housekeeping tips to maximize the value of your webinar. To ensure the best connection possible, please close out any programs or apps that may be eating up a lot of data in the background to free up your bandwidth with space. If you experience any technical issues, please call the help desk support line at the number provided in the chat box. You can join the audio using your computer. However, if you would prefer to join over the phone, just select telephone on the audio pane and the dial-in information will be displayed. This will also help clear up some bandwidth. Your audio settings will be set to listening only for the presentation portion of the webinar. You'll have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. Any unanswered questions will be followed up via email following the presentation. If you would rather ask us a question directly rather than type it, raise your hand and we can unmute you. Today's webinar will be recorded and available on demand, and a link will be sent out to all attendees within the next 48 hours. So, without further ado, I would like to introduce Solomon Chiang. Solomon is the Director of Research and Development for the Gun Company. Solomon is a recognized leader in the industry and currently chairs the ANSI NEMA Industrial Laminate Advisory Technical Committee. He chaired a working group in 2021 with the task to update the NEMA LI 1998 standard and seek ANSI American National Standard recognition. He is currently chairing another working group to update the NEMA LI 1993 standard. Solomon is also a technical advisor to the IEC TC15 standard committee representing NEMA and ANSI. With a PhD degree in chemistry, plus over 30 years experience of industry experience, Solomon leads the Gun Company research and development efforts. He offers a unique and practical perspective on material selection and application problem solving. He's helped many clients achieve performance improvements and cost efficiencies through countless R&D initiatives. So without further ado, Solomon, you can take over.
Thank you, Mike. Welcome, ladies and gentlemen. Good morning, afternoon, good evening, wherever you are. And thanks for spending time to join us today to talk about NEMA Grade Thermoset Laminate Insulation. The agenda is as follows. I'll give a brief background and history of NEMA Grade Thermoset Laminates. And then the next two topics are the meat of today's presentation, the detailed reviews of the NEMA Grade Thermoset Laminate. Right now there are 37 of them in IM 60000. And we will talk about the properties of all the different NEMA grade thermoset laminates. And then I will touch base and spend some time to talk about the new NEMA grade that's been added in the new IM 60000 G12, G13, G15, and GP05. And lastly, we'll talk about how do we optimize our product design with NEMA grade materials. A bit of introduction on NEMA. I realize that most of you are very familiar with NEMA already, so bear with me. So NEMA stands for National Electrical Manufacturers Associations. It's comprised of many divisions, and each division is comprised of several sections, and each section is responsible for several NEMA standards. I think NEMA have about 200 standards. So they are the responsibility of individual sections. LI1, or the IM 60000, that's what it's currently called now, is the responsibility of Section 6IM 6IM means Section 6 Insulating Material, and we work under the Industrial Products and Control Division of NEMA. And the difference between the insulation that's covered by Section 6IM and other insulation, such as the receptacle on the power cord, on the laptop, and the cable insulation on the power cord, is that we are dealing with insulation used by large industrial machinery like generator, a large motor, and transformer. They are under much higher electrical, mechanical, and thermal stress, and they meant to last a long time. They are not consumer products. So this is one of the reasons why there's a need for a common standard to speak to the requirements of the insulation, so we can ensure that the appliance or the industrial equipment will last a long time. The IM6 has about 9 standards. 2 of them address thermoset laminates. The key one is what we used to call LI1, and that's been updated to IM60000 now, and that addresses the properties of 37 NEMA grade thermoset laminate. That standard is supported by the one that's currently under review called LI6. It is relative temperature index of the 37 grade of NEMA thermoset laminate. I will not go into that one, but in today's presentation. But if you have any questions that you want to ask us about LI6, please feel free to ask us. Okay, the LI1 is the main standard of NEMA, which is now ANSI NEMA IM60000 2021. The key thing that I want to talk about, the key difference between the IM60000 and LI1. First one, LI1 was not an ANSI standard. IM60000 is now an ANSI standard. ANSI stands for American National Standard Institute. So it is the American National Standard IM60000. And all the new grade and all the NEMA grades are now ANSI grade as well. The other thing that I want to talk about today is that we have introduced new grades in the IM60000 standard. New doesn't mean that they were invented last year. They've been around in international standards. So we just brought IM60000 to current with other international standards to reflect the advancement in the industry. And talking about international standards, we add to IM60000 properties both the SI unit or metric unit side by side with a US imperial unit to facilitate any comparison between NEMA standard, NEMA material, and international standard like ISO, IEC. And one other thing that we did when we revised IM60000 is that we clarified the difference between requirements and typical values. Requirement would have minimum or maximum in it. So if a property has a minimum or maximum, that means it has to exceed the minimum and it has to be below the maximum. So that is one must conform in order to be classified as NEMA material. Typical is a bit different. Typical is average values of certain property for a particular material as conducted by different manufacturers' laboratory. It is there like a reference, so doesn't mean that you need to meet it, but that's the reference value of the material. So the NEMA standard actually started almost 100 years ago as a standard for phenolic. Think about bakelite. That's the original process, and that is a type of phenolic. And throughout the year, I will go into it a little bit in a bit more detail when I talk about the different grades. But one thing that I want people to remember is that NEMA standard, the NEMA grade designation like GPO3, G11, FR4, they are in millions of customer join. Why? Because a NEMA grade become very popular in the 80s. In the 80s, U.S. military decided they are not going to maintain the MIL standard anymore. They want NEMA to take over. So some of you, if you look at the drawing in the 60s, it may say MIL standard, but the newer drawing, especially for U.S. company, when they talk about thermoset laminate, you will see the NEMA name there, GPO3, G11, FR4, G10. Whenever people mention those names in the drawing, they are implicitly referring that the material has to meet NEMA standard. So the standard applied to a layer composite commonly used in the industry. Nowadays, most people would call thermoset laminate as thermoset composite. The reason why NEMA used to work thermoset laminate is that layering of B stages or PPAP and then subjected to high temperature and high heat was the original way of making thermoset composite and still a very popular way of doing it. So by saying laminate or composite, I'm talking about the same thing. And one thing that I'd like to point out here is that there are other composite types that are used in the industry. They are not part of the NEMA IM 60000 now, and they will not be part of today's discussion. They are like the filament rounded tubes, the BMC compound, or a thermoplastic composite like filter nylon or filter polycarbonate. They are important material, but they are not part of NEMA IM 60000 at the current time. So to give everyone a break, and before we proceed, we would like to conduct one poll question first.
Yeah, so our first poll is just to see how often you use the materials in the NEMA LI1 standard. So if you can just select one of these on the poll, we'll give you about 30 seconds. Okay. Looks like we're getting all of the answers in. Okay, so we've got a good range of people that have used it a few times, but quite a few of you have used it. You use it a lot. So 60% of us are using it all the time. So, but a few of you are new, very, very new to it. So that's good. That helps us understand where everybody is. Thanks for participating.
Thank you. So for the 40% of us only use NEMA grade material a few times. So this is just a very simple way of describing what is a NEMA composite. Essentially, A, substrate, plus B, the resin, the organic compound, equal to C, the composite. And the combination of the substrate or the fiber plus the resin, that's the chemistry, the chemical, provides the inherent properties of the NEMA grade material. In addition, there are fillers and there are additives that we add to the composite to enhance the properties. It's either the finished material property or the processing property. The bottom is a good example. The fiber is a roll of glass mat. So we roll it out and then cut it into rectangular shape, and that's how we prepare our glass package. Sometimes we have to use a combination of different type of glass. And then we put it in an open mold, and on top we add the resin. and we mix the additive in the resin, and then we add it to the glass package and use the heated press, and over a certain period of time, we would have a solid piece of NEMA grade laminate coming out. And okay, NEMA grade, as I talked about before, it started almost 100 years ago with phenolic material as the resin or the chemicals, and then the substrate, the fiber start with paper and then move up to cotton or fine cotton like linen. And after a few years, people realized that they want the material to be more fire retardant, so they start to add melamine in it. So melamine become a NEMA grade. And then around the Second World War, people recognized that we need the laminated material to be stronger. So at that time, what is stronger than paper or natural material like cotton? Woven glass cloth. And that's why we have those glass grade G3 to G9. And after the Second World War, due to the advancement in the polymer industry, epoxy become very popular. So epoxy glass become a very popular NEMA grade. And then a bit later on, we have unsaturated polyester, and they are added to the NEMA grade also. And in the 90s, the last two, the CEM1 and CEM2, they are special grade for printed circuit board. Obviously, that was popular in the 90s. And nowadays, they sort of gone out of fashion because of the industry has moved on. But we kept them on as NEMA grade. And if you look at it, some of the ones that I highlight, the G15, GPO5, G12, G13, they are new NEMA grade in IM 60,000. They've been around for 10 years or more, and they have been in the IEC grade. And unfortunately, as I said, NEMA became very popular in the 1980s, but the last time it was revised was 1998. So we kind of missed the advancement in the industry, and that was another reason why we revised NEMA LI1 into IM 60,000. Now we have our next poll question.
Yeah, so what we really want to see here is what properties are most critical to you in your applications. And you can select more than one, I believe, even though it says select one. So if it doesn't allow you to select more than one, then don't worry about it. Just select the one that's most important to you. We'll give you about 30 seconds to go ahead and complete the poll. Okay. All right, very good. Sharing. And it looks like, again, there's a good balance between mechanical and electrical, some thermal characteristics that are very, very important to people. So, again, it gives a good idea of where everybody is with their needs and their applications.
Yeah, thank you, audience. We have a very knowledgeable audience because that was what I was going to say. Okay, NEMA, after all, is National Electrical Manufacturing Association, so electrical properties is obviously important. And IM6 is the Insulating Material Section, so we deal with insulation. And we proud ourselves because insulation is a very important part of the electrical system. Without it, we cannot use electricity. A good example is the water pipe, because we need a water pipe to direct where the water flow. The same thing go with the flow of electron. It's the insulation that direct and control the flow of electrons or electricity. And the example is the thing about Niagara Falls. As another way of looking at Ohm's law. Ohm's law is voltage divided by resistance. equal to current. So with Niagara Falls, the height of the fall is the potential, the voltage. The water flow is obviously like a flow of electricity or electron. And then the resistance is rock. And if you build enough rock, you can actually stop the flow of electricity or the flow of water, like Hoover Dam. But we don't just want to stop the flow of water or electricity. We want the water to go somewhere where we want it to, so we can direct the water to go into the turbine room and use the flow of water to generate electricity. So essentially, this demonstrates how important insulation is as far as controlling the use of electricity. And here are the 5 properties most that you will see in almost every NEMA grade material. And remember, I mentioned that thermoset laminate, by saying thermoset, we are talking about plastic, organic material. They are all pretty good insulation on their own, especially for household usage. But for critical industrial application, there may be some situation that you want to choose the best or the first among equals. So those are the situations that the material will perform best in specific situation, like breakdown voltage. If that's critical, those are your choices. Arc and trap resistance, again, those are your choices. Permittivity, that's that dissipation factor. Again, if you worry about heat loss, if you worry about energy efficiency, those are popular choices. The mechanical properties for NEMA grade material, in my opinion, is almost as important or just as important as electrical. And the mechanical properties are primarily influenced by the type of substrate or fiber you use. Glass is obviously stronger than paper. Everybody know how strong glass fiber can be. But the other one that's very important is that the orientation of the fiber to mechanical stress is very important also. And that's why when NEMA published its standard, all the mechanical properties, NEMA would identify whether it's lengthwise or crosswise, whether it's perpendicular or parallel to the lamination, whether it's flatwise or edgewise, if we are talking about something like compression. So that's one thing that makes NEMA standard very useful in design engineering, is that if you know your force is concentrated in certain direction, you can select the right material. And here are the properties that you can find in the NEMA IM 60,000 standard for each material grade. As I talked about before, there are requirements, there are typical values. The first 2 are always requirements. And then the next 3, sometimes they are requirements, sometimes they are typical, depending on the grade and because they came from a lot of knowledge. Why certain material, certain property is required, but it's only a typical for certain other grades. And the bottom 3, they are usually just typical values listed by NEMA and for consumer or for user to use as a reference. Okay, this pyramid, the reason I put this pyramid is that I want to show how the different fiber would affect the mechanical properties. S glass at the top of the pyramid has the highest or the strongest mechanical performance, and followed by the woven glass cloth, and cloth is stronger than glass mat, and paper, cotton, and linen is near the bottom. Nylon fiber is kind of weak, but nylon fiber material, the nylon gray end, is used for a very specific reason. So after mechanical properties, the third properties that the NEMA standard show are what we call physical properties. Of all the physical properties, the most important one is probably water absorption, because we are talking about a standard for electrical insulation. So electricity and water, they don't mix too well. And on top of that, in situation where the NEMA material or components made out of NEMA material is exposed to, say, high temperature and humid environment or hot water, water absorption would have an effect on the longevity of the components. Essentially, what prolonged exposure to high humidity would do is that it actually degrade both the resin and the fiber through a chemical reaction called hydrolysis. And also the boundary, the water film will form a boundary, and that will cause partial discharge at certain voltage that's high enough, and that would affect the long-term performance or the longevity of the insulation used. So that's why water absorption is a very important physical property. And of the NEMA material, the silicone gray has the best water absorption performance, followed by epoxy and polyester and phenolic. Those are the original NEMA gray. Obviously, glass absorbs less water than paper or any natural material. And density is a fairly important consideration. And what it is that, in general, it's just a general rule of thumb, the higher the density, the stronger is the material, because there's more material. But the other thing is that if all other properties are equal, material, the NEMA grade with the lowest density, is actually has an advantage in terms of weight, and that may be important for aerospace or even wind turbine application. And it's usually the lower the density, the cost may be lower because you use less material. Thermal properties. Yeah, we have a very knowledgeable audience here. Room temperature, the property is one thing, but elevated temperature property is another thing. And on top of that, we need to talk about thermal endurance, or RTI, or the thermal class of the NEMA material grade. I mean, in large industrial machinery like generator, rotor, or dry type transformer, they operate at very high temperature. So, and then they are expected to last for a long time. So that's what we call RTI, or thermal life property. So those, I don't have time to go through it in detail here, but the NEMA IM 60,000 or the OLI1, for each material grade, the temperature class or the thermal index is listed, and they are usually listed under typical value. And where do those numbers come from? They come from the NEMA LI6 standards. And the LI6 standard, NEMA actually have an entire different standard just to address the thermal properties of its material, of its thermoset laminate, that demonstrate how important it is. So, of the NEMA grade material, the the polyimide are the one with the highest thermal performance, followed by epoxy, vinyl ester, and then standard epoxy, followed by high-temp epoxy, vinyl ester, and then standard epoxy and standard polyester, phenolic, and melamine again at the bottom. Again, glass obviously have a higher thermal endurance than paper. Okay, I think this is covered the last properties. Chemical properties, the most important one. I mean, obviously, a lot of you at the audience know about flammability, UL94, and that is influenced mostly by the chemistry and the additive, the flame retardant additive. And then, as a rule of thumb, polyimide has the highest chemical stability, followed by silicone, high-temp epoxy, vinyl ester, and then unsaturated polyester, phenolic, and melamine. Melamine is very good on the flammability, but it's not chemically as stable as polyimide, silicone, and high-temp epoxy. I mean, high-temp epoxy, some of them will require a bit of additive to make it UL94V0. Last one, this slide looks familiar because this pyramid is the same as the last two that I shown. Essentially, it's telling us that in this world, you have to pay for everything. So the high-grade material costs more money. Okay, I would like to go through the new NEMA grade. Start with G12. Okay, everyone knows the NEMA temperature class. Class B, G10. Class F, G11. Class 12, what it is? It's a Class H, 180 degrees C, NEMA glass polyester, glass epoxy. And then there's another one called G13. So if you look at it, G13 is Class H also. But what makes G13 special over G12? In case you need very high track resistance, and in our industry, there's a test called CTI test. It's very hard to get to 600 volt. That G13 material meets the 600 volt CTI, and it is also used in Europe. They use it for railway application because the toxic is a smoke and toxicity grade. And we have tested the G13 material and find out that not only that it meets the European EN 45545, also meet the North American NFPA, National Fire Prevention Association 113. G15, this is the polyimide, very expensive material, but it outperforms any of the glass grade at extreme temperature. Look at it. I mean, class R is 220 degrees C. It retains 60% of the room temperature performance when you test the material at 220 degrees C. And it retains half of its room temperature performance at 260 degrees C. And that's indeed a very high temperature. Last one, this one is called GP05 under IEC's UPGM 205. It is a high-strength glass mat polyester laminate with mechanical properties approach that of a glass epoxy grade, but maintain the GP03 frame track and arc resistance. If you look at it, the comparison between GP03, GP05, and G11, it is actually very close, much closer to G11 than GP03. It's a bit more expensive than GP03, but it's very cost competitive to G11. So, lastly, okay, now that we talk about all the NEMA grade and all the properties, so I'm a product design engineer. I have a specific application. How do I know which one to use? So first, we have to identify what are the critical properties in the application. Is it electrical? Is it thermal? Or is it mechanical, or combination of all of them? And then we look at available NEMA grade for best options. And obviously, what we learn from a from a standard is one thing. We had to we had to get some material and perhaps make some actual components for doing testing. So we are talking about both material testing and prototype testing. And once it passes those stages, then we obviously will want to do some application engineering testing. It can be an accelerated life test, or it can be a full fledged end product testing. And then there are always the question mark that I don't see that property that I need in your NEMA grade, so what am I supposed to do? And also, there are other question marks like I think my material or my component is subjected to a combination of stress. It's not just compression, it's compression and flex. So how are we going to test it? Okay, we test it in the prototype. See, the gun company, we have done that for our customer many times. I mean, you can always contact us, and then we can go through your application and the NEMA grade together and develop jointly some sort of test plan to test the material, to test the component, or even test the end product. See, at the end, this essentially comes to the end of today's seminar, and we will send out the presentation, the recording of the presentation, plus the PowerPoint. And the PowerPoint will have links to our website, contact information, and also we have links where we compare the properties. We have a large table so that we can compare the properties of all the NEMA grade, so that you don't have to flip through 220 pages of standard to find the one that you want.
Yeah, thank you, Solomon. Yeah, for those of you here today in attendance, we have some handouts available for you to download. There are some comparative data sheets showing the properties of different materials that are available. Some of the NEMA grades that we talked about today, some of them not NEMA grades, but you can also find additional comparative data, as Solomon mentioned, on our website. I believe we're putting a link to that in the chat. And now that we've completed the presentation portion of this, we can begin to answer some questions. I see that we have a few questions from the audience. And if anybody also just wants to ask a question out loud, you can raise your hand. But I'll start with some of the questions that we got from the audience. And it looks like we have a question from Tom Hawkins. Thanks, Tom. Tom's question is, why is tensile strength listed as a typical property and not a required property when a lot of composites are used as bus braces and subjected to tensile loading?
Yeah, that's a very good question.
Yeah, I think so.
Yeah, and then I guess it has to go back to how the NEMA standard was originally developed. At that time, they considered compression and flex as the most important mechanical property, and that's why they listed under requirement. And I realized that nowadays, I mean, in some bus bar application, tensile is an important consideration. So, when the NEMA has committed itself to revise the review standard every 5 years or so, at the next revision, we will bring it up, because I think between the NEMA company, we have enough tensile data to make it like requirement.
I think, and I'll just add to that a little bit, I think, Tom, that one of the reasons they do that is just from the ease of the test. You get, flex is a kind of a combination of tensile and compressive properties, and it gives you an indication of tensile. But tensile testing is a much more difficult test to perform than flex testing, so they don't make it a required test for like quality purposes, so to speak.
Excuse me, Tom, did you have any additional information you wanted to ask?
Yeah, can you hear me?
Yes, sir.
Yes.
Yeah, so my question is, um, t- what properties can we expect, or do you guarantee for tensile on your data sheets? Do they, is there a minimum?
So when we do our testing, we are trying to provide a typical that is like a nominal value. We're not putting a minimum on there. And if you are trying to design to a minimum, then I think we would have to give you a minimum number that you could go for and put into your design.
Okay.
That's probably not, you don't want to use the typical value on the data sheet for you if you're looking for a minimum.
Something that we can put into a purchase order if we agree to a certain number.
Yeah. We will typically, if somebody needs a minimum tensile strength, we can add the customer specific requirement.
Okay. And is that true of all of these materials, or just the GPO3 and such?
I think that there's no NEMA requirements. Anything in this IM 60,000 standard is going to be only, there's no tensile strength minimum requirements. It's only typical.
Okay. Well, Solomon, if you're still around in 5 years when they redo the standard again, I would suggest we try to get that added as a requirement.
Yeah, I mean, we start to see people requiring a certain tensile property due to the application.
Yeah. Yeah, and I'll say, just to add to that, the IEC standard doesn't include tensile either. And so that could, he's on the IEC committee, so he could also bring it up there in the international standard.
And actually, I think in most cases, they only do a flex. They even kick a compression to require to a typical.
Yeah. Good question. Thanks, Tom.
Okay. And then one other unrelated question is, the new standard, is it available free of charge, or do we have to buy it?
$420 from me.
Oh my gosh. Okay.
Nothing's cheap these days, right? Okay. Looks like we've got a couple other questions in here, and let's see, question from David Young. Does chemical stability mean reactivity with acids, bases, or degradation by UV, etc.? Are there laminates that excel at both 150 C and cryogenic temperatures? So that's kind of a combo question there. So take the first one first with the chemical stability and reactivity, acids, and degradation, and so forth.
If you look at the NEMA standard, in many of them, they talk about corrosion resistant oil, sometimes maybe the saline or coastal application, but they are all in the typical value. And if we are talking about something like UV, that's not covered by NEMA. I mean, weathering, outdoor weathering resistance, that's actually covered by UL 746C, and that's not part of the property leased by the NEMA material grade. But again, I mean, if you are looking for a specific outdoor or chemical properties, I mean, the gun company, we have done a lot of what we call the immersion test, as well as UV aging for customer. So again, those are, if you go through the NEMA standard, they do talk about there are certain things that would be settled between the customer and the supplier. What property you want, put it in your purchase contract.
Yeah. And then the same goes for cryogenic temperatures, I believe. And they deal more in the NEMA standard with the high temperatures as opposed to cryogenic temperatures. There's really nothing in the NEMA standard on cryogenic, but it definitely covers the higher temperatures, and you can look through the standard and see where it's covered.
Mhm.
Hopefully that answers David's question. Okay. Have a question from Arthur Shell. You were asking if you could get the data properties for the NEMA grades, the new NEMA grades. And I think that the easiest answer to that is, first of all, you could buy the standard, which we just said was pretty expensive. But the other thing you can do is you can find the data sheets on our website, and in our data sheets we actually list
A column.
a column for the NEMA requirement. So if you don't find what you're looking for, please just send us a note. And then we have one from Kelsey Kennedy LeBlanc. What is the thermal performance standard that you mentioned during the thermal properties review?
That will be the NEMA. There are many of them. The NEMA one is called LI 6, and then people talk about UL 1446. The one thing that distinguishes NEMA LI 6 from all the other RTI standards is that NEMA LI 6 actually provides the RTI of 47 different materials, different thickness that they test. And a lot of the other standards like UL 1446 or the IEC equivalent, they spend more time talking about the test method. So if you are looking at numbers, you will find it in NEMA LI 6 a lot more than UL 1446. UL 1446 tells you how to do it, but they do not list the properties of the material that they have tested because those are confidential.
Kelsey, we have actually a full technical white paper on that topic. So if you would like, we can send you that. Next one is from Chao Zhang. Zhang, your question is, in G10, G11, G12, the thermal class is enhanced by resin or glass mat or both? I'd say primarily the resin.
Yeah. I mean, there are different types of epoxy. The one that you can buy from Home Hardware, those are what we call standard grade epoxy. But then there are much higher temperature epoxy, and those are used in G11, G12, G13. So we call it high temp epoxy.
Okay, and we got one more question here. One from Jagdish Bird. Can you please confirm that the GP grades are suitable for FR3 transformer liquids in compatibility with mineral oil and FR3 indicated on the data sheets?
We've done those type of tests before, and essentially the customer supply us with the transformer fluid, and we will perform the test for you.
Yeah, I would say in general, it's not in the NEMA standard whether or not something is compatible with oil. Mm-hmm. And it really actually, you could buy a G10, let's say, for example, and one G10 might be better, more suitable and compatible than another. But overall, every G10 should be compatible with mineral oil.
Yeah.
You know, epoxy is compatible with mineral oil, and it should be compatible with FR3 as well. Mm-hmm. But we will typically recommend that you do those tests and do a test just to verify that whatever you're buying is going to be compatible, and it's a very easy test for us to perform.
You can see here epoxy is very high up on the hierarchy as far as chemical stability. Polyimide is always the highest, but essentially that's very expensive.
Okay, I'm going to take one more question, if that's okay. How is compressive strength changing for temperature class B and F? And so I just want to make sure I understand this question correctly. This question is from Mo Golami. And Mo, just to make sure I understand this, you are wondering if it changes when just from the material at room temperature, or you want to know if it actually compressive strength changes when temperature is going up on a material and the material is exposed to higher temperatures.
Hello?
Hey, Mo, yes.
Hi, thank you for the presentation. Yes, exactly. I wanted to know how the material properties, the compression strength changes from room temperature when we go to class F or class B.
Okay. Yeah, definitely compressive strength is one of those that is highly affected by temperature. So, you know, we actually recommend doing the test at temperature whenever somebody has an application that's going to be consistently at a certain temperature, and we'll perform those property tests at the specific temperature. But we actually have some of our products that are used, you know, at higher temperatures all the time. We have curves, and you can see a certain drop off, and there's actually kind of a cliff. In every material, there's a cliff. When you hit that cliff, your compressive strength really falls fast. So you have to be careful where that cliff is with each different material. And I would just say in general, that cliff kind of coincides with the glass transition temperature.
Yes. And also, not for everyone, but for certain NEMA grade, if you look at the properties, and they would have the test condition. If you see a T130, T155, that material is tested at that temperature, and you can pick off that property at that temperature compared to the room temperature.
Yeah, if you have a specific application or temperature you need to test and property you're looking to test, you can email us directly and you know, contact us, and we'll try to work with you on whatever application you're working with. Okay, well, I think that will okay, we have, oh yes, sorry. You can email more questions, and we will definitely answer all of those questions that come in. If you didn't get your answer today, we'll send out the answers via email. And by the way, we are having another webinar in May, and it'll be Composites 101. I'll actually be the presenter for that webinar. So thank you for joining us today, and hope you have a good rest of your day.
Thank you.